Well, we have another question over here, question 4. The question says that the graph of f of x equal to log of x base 4/3 is drawn below. B is a point on f. Now, question 4.1. The question says that for which values of x is log of x base 4/3 is lesser than or equal to 0. Now, I'll write the question over here. We have like question 4.1. So I'm gonna write here 4.1. So we're looking for the value or values of x, okay, for which log of x base 4/3 is lesser than or equal to 0. Now, we need to remember that the log formula, or by log definitions or formula, log of a, okay, base b equal to x implies that a equal to b to the power of x. Okay, so now in this situation, it simply means that x equal to must be lesser than or equal to 4/3 to the power of 0 from the formula. And that means that x is lesser than or equal to 1, because everything raised to the power of 0, okay, it's just 1. But now we need to be careful here. It's not complete yet, because if I said x is lesser than 1, it means it can be like, it can be 0.97, it can be 0, it can be -1, it can be -2. But we know that logs functions do not accept values that are 0 or lesser than 0. You can check it in the calculator. First of all, we can maybe look at the number line here. So we can illustrate 12. So if the 1 value is here, okay, lesser than 1, less than or equal to 1 means from 1 here and then all the values there, and then this includes even the values that are smaller than 0. Now, but the log functions can only accept positive numbers. Now check this out. If I do, for instance, in the calculator, say log of like, let's say like 0, for instance, okay, this leads to math error. But now, so therefore, I need values that are more than 0, okay, and lesser than 1. Therefore, the values of x will be 0 must be lesser than x, not equal, but lesser than x, and then x must be less than or equal to 1. So this is the accepted values of x. Excuse me. Now, the following question is question 4.2. The question says, determine the value of p without using a calculator. So now we have like b is a point 16.9p. So they all lies in this log function here. Now it simply means when x is 16/9, y is p. So the function is, okay, let me first write the question. So it's question 4.2. We're looking for the value of p. Okay. We do know that the function is y equal to log of x base 4/3. Now, in this situation, I said over here that the x value and that y value. So we can sub in the values, okay? Instead of writing y, we can just write p, okay, equal to log of, instead of writing x, we're going to write the value of x, which is 16/9. So maybe 16/9 base 4/3. So according to the formula that I wrote here in red, okay, this is going to be like it's like 16/9 would be equal to 4/3 to the power of p. Okay, so this will be 16/9, or let's just keep the unknown on the left. So it's like 4/3 to the power of p equal to 16/9. Okay, and then we can write this like, we have like 4/3 to the power of p. Okay, and then we can reduce also 16/9 because 16 is like 4 squared, and then 9 is like 3 squared. So I do that because, you know, we have exponents to both sides on the numerator and the denominator. So this can be written as 4/3 to the power of 2. Remember this law of exponent that says if you have like a to the power of m over b to the power of m, this can be written as a over b to the power of m, like that. Okay, so then we have like the bases are the same here, and then we're going to equate the exponents. So therefore p is just equal to 2. So that the value of p is equal to 2. And then comes question 4.3. The question over here, excuse me, the question says that write down the equation of the inverse of f in the form y equal to. So I'm going to do it over here. Move my board like that. So question 4.3. So we're looking for the inverse of f. We're looking at f minus 1, but in the form y equal to x3. Now f of x is y, so we're going to write y log of x base 4/3. So this is for f. Okay, now f minus 1 is when we substitute, actually we switch the variables. Okay, we call y x and then x y. So it's going to be like x equal to log of, okay, of y base 4/3. Now we're going to make y subject of the formula. Okay, so this will be 4/3 to the power of x equal to y. Now, so we can just write like y equal to 4/3 to the power of x. That's the inverse of f in the form y equal to. Okay, can just make it a bit like anyway, leave it like that. And then comes question 4.4. Question 4.4 is here, and then the question says question 4.4, the question says write down the range of y equal to f minus 1 of x. Now 4.4, looking for the range of f minus 1 of x. Now f of x is this exponential function 4/3 and then the power of x, like that. Now the range will be all the acceptable y value. Okay, so in this case, you know, exponential function is always positive. So regardless of the value of x here, y will always be positive. Whether x is positive or negative, y will always be positive. So okay, remember, y is just f of x. Let's just write y here. Right here, we say that y is positive, strictly positive, okay, to 0. Or we can also write like y is element of this interval. Let's write it underneath. Okay. I'll write it here. Y is elements of the interval 0 to positive infinite, like that. So this is the solution. And then we have another question. It's question 4.5. The question says that the function h of x equal to 3/4 is obtained after applying 2 reflection on f. Now write down the coordinates. Okay, I think I have the question here. The question 4.5 says that the function h of x equal to 3/4 is obtained by after applying 2 reflection on f. Write down the coordinates of b. BH, the image of b on h. Now I think I'm gonna write the equation over here. 4.5. Looking for the coordinate of BH. Note that BH is the image of B on H. And then okay, h of x is given by 3/4 to the power of x. Okay, now 2 reflections here. Okay, what does it mean? First of all, I'm gonna write the point B. The point B was given by it was 16/9 p, and then we find the value of p was 2. Let's double check. Let's see. Yeah, p was found to be 2, and then 16/9 p. Yes, that was the point B. Now we're going to reflect it twice, okay, on f. So this simply means we are going to do the first reflection on f. It's going to be 2 16/9, okay, and the other reflection will be that's my calculator. I mean, yes, the other reflection will be will make a negative here. So 2 reflections. You can check this out. If I sub in -2 on h, I will have okay. Let's sub. Sorry about that. If I sub in -2 16/b on h of x, okay, this is bh now. If I sub that, this will be h of -2. Okay, we know h of -2 is 16/9. So 16/9 would be equal to okay, maybe let's just do this. On a sub, I need to find the value of y. If I sub -2 on 3/4, okay, and then this will be equal to you know, when you have a negative exponent like that, you can write 4/3. You can reverse and then make it right with a positive exponent, and of course this will make what 16/9. Then so BH is -2 and then 16/9. Thank you.